Solar photovoltaic systems are recommended to be grounded. This means the DC negative side or DC positive in some cases is solidly connected to ground at a central inverter. 690.41 section A4 of the National Electric Code allows the system to be ungrounded though. Grounding does maximize the life of these panels, which is why it is recommended. Regardless of whether the system is grounded or ungrounded, the National Electric Code does require ground fault protection. 690.41 section B of the code says this is to, quote, reduce fire hazards, unquote. A few of the central inverters that are commercially available do meet the requirements of the code, but unfortunately miss the spirit and actually increase fire hazards instead of reducing them, which is the spirit of the code. Remember, the code is published by the National Fire Protection Association. Their entire mission is to reduce fires. So how do these inverter OEMs miss this? The answer is by putting in inferior components not rated for the application, specifically for the power path that handles the fault current. Components that can handle fault current have an appropriate interrupting rating. 110.9 of the code says the equipment intended to interrupt current at fault level shall have an interrupting rating at nominal voltage at least to the current that is available at the line terminals of the equipment. If the component is not properly rated, then the component can violently rupture and propagate to other areas, causing further arc flash damage. UL 248 has many pass-fail criteria for establishing this interrupting rating. The first is the design setup, or the test setup. The proper fault current, the proper recovery voltage, and the proper time constant must be calibrated first for some tolerance model. The fuse and holder are then subjected to the fault and recovery voltage. The fuse shall clear and not re-establish current. The fuse shall not emit molten metal nor have holes in the fuse. The fuse should not increase more than 1/4 inch in length, and the markings on the fuse should be visible. The inverter OEMs also sometimes use an inferior wire gauge when connecting to these fuses. All wire has a damage curve that follows an I²T curve. The designer needs to ask himself or herself what will be the duration that the wire will see the fault current and what is the maximum fault current it will see. Then he or she can look up what wire to use based off the damage curve. Chart 250.122 in the code has these damage curves baked into that chart. So what is the main takeaway from all this? The main takeaway is simply awareness. Do not skip on your PPE and other administrative controls listed on your job hazard analysis. There is always the possibility of an arc flash, and be aware that the likelihood is higher when these inferior components are utilized. Be safe out there.